Hi, sir! So, this is my third and final video recitation. And in this video, I will show you how to solve an example of a work word problem. And it is divided into 3 sub-problems. So, let's go! So, we have here our main problem. Stated in a certain swimming pool, Pipe A can fill the pool in 5 hours. Pipe B can fill the same pool in 10 hours, while Pipe C can drain it in 15 hours. Earlier, I have mentioned that it has 3 sub-problems to be solved. Sub-problem A, if all pipes are open at the same time, how long will the pool be filled? Sub-problem B, if Pipe C has been open for 1 hour, how long will the pool be filled? And sub-problem C, if Pipe C was not opened, how long will the pool be filled? So here, I constructed a table showing the data content from our main problem. So let's complete the table for time to finish the work. In here, Pipe A can finish the work or fill the pool within 5 hours. Pipe B can fill the pool within 10 hours. While Pipe C can drain the pool within 15 hours. In the second one, we're going to get the fractional equivalent of work they have progressed over an hour. So, in Pipe A, we'd have 1 over 5. In Pipe B, 1 over 10. And in Pipe C, 1 over 15. These fractional parts are considered the rates for our formula. In order to solve the 3 sub-problems, we must know the formula first. Here we have work is equal to rate times time. So let's solve sub-problem A. Let's go back to the question, if all pipes are open at the same time, how long will the pool be filled? Since all of the pipes are open in this problem, we are going to use all of the pipes in the equation. As we have mentioned earlier, rate is going to be the fractional part or the fractional equivalent of the time to finish the work between the 3 pipes. And since time is not available, we will refer to it as x. So, let x be the time for all the pipes to fill the pool. So we have to add the work of Pipe A to the work of Pipe B and subtract the work of Pipe C since it is the one draining the pool. So our equation would be the rate of Pipe A multiplied to its time, which is unknown, so it's x, plus the work of Pipe B, rate is equal to 10, multiplied to x as time, and subtract to the work of Pipe C, which is the rate, 1 over 15, and multiply to the time, which is x. And then we'll equate it to 1, since all of the rates are counterparts of work within an hour. And here, we're going to find the LCD between these 3 denominators, which is 30. 30 is divided by 5, 6, so it's 6x, plus 30 divided by 10, is 3, so it's 3x, and 30 divided by 15 minus 2x. 30 multiplied to 1, of course, is equal to 30. And now we are going to simplify. 6x plus 3x is equal to 9x, minus 2x is equal to 30. 9x minus 2x is equal to 7x. Equal to 30. To isolate x, you have to divide it by 7. And there we have x is equal to 30 over 7. Or, it would take 4 hours and 2 over 7 minutes to fill the pool. Now that we have solved the first subproblem, we will move on to subproblem B. The question is, if pipe C has been opened for 1 hour, how long will the pool be filled? So if pipe C has a starter time of 1 hour before the other two pipes have been opened, this serves as pipe C's time. Since all the pipes are still involved, we are going to use pipe A, B, and C still in this equation, leaving X as the time representing for pipe A and B. So now we are going to let X be the time for all the pipes to fill the pool again. Just like the first equation, it is still the same. But for pipe C, instead of X as a representation of its time, we put 1 since it was ahead for 1 hour. So, 1 over 5x is the work for pipe A plus 1 over 10 times x for the work of pipe B minus 1 over 15 times 1 since it was ahead for 1 hour for the work of pipe C. And it is still equal to 1. And then the LCD is still 30. So we use 30. 30 divided by 5 is equal to 6 times x, 6x. Plus 30 divided by 10 is equal to 3 times 1 is equal to 3. And then it's 3x. Minus 30 divided by 15 is equal to 2 times 1, it's 2. And then 30 times 1 is equal to 30. Since this has no x variable, we put it to the other side. 6x plus 3x is equal to 30 plus 2. And then 9x. And then 32. So, from the previous equation, we have 9x is equal to 32. To isolate x, we have to divide both sides by 9. Then we have x over 32, 9. And another term is, it would take 3 hours and 5 over 9 minutes to fill the pool. Now that we have solved our second and first subproblem, it's time now to go to our third subproblem. And if pipe C was not opened, how long will the pool be filled? So now, pipe C is not involved in this problem. So we only have pipe A and pipe B to worry about. Since pipe A and pipe B are the only ones involved in this problem, we will be only seeing the rates and the time for pipe A and pipe B. So, let X be the time for pipe A and pipe B to fill the pool. Unlike the first two subproblems, our equation would only consist of the work of pipe A and the work of pipe B. So, for the work of pipe A, the rate 1 over 5 times the unavailable time, which is x, plus 1 over 10, and its unavailable time, or its representation, x. And we still equate it to 1. And since pipe C is not around, the LCD will change. So our LCD for 5 and 10 is 10. And so now, we perform the operations. 10 divided by 5 is 2 times 1 is 2 times time x plus 10 divided by 10, 1 times 1 is equal to 1, and multiplied to the time, which is x, is simply x. And then 10 multiplied to 1 is equal to 10. And so all we have to do now is simplify. From the previous equation, 2x plus x is equal to 10. 2x plus x is 3x equals to 10. Then to isolate x, we have to divide it both sides by 3. And then we have x is equal to 10 over 3, or in simpler terms, we have the time as 3 hours and 1 over 3 minutes for the pool to fill. So, hi sir, that is how you solve an example of a work word problem. And it actually took me 10 hours for this whole operation, from recording to editing and to uploading it on YouTube. And even though it's very time consuming, I actually enjoyed this work problem, and it's actually my favorite from all of your lectures. So thank you and bye.